Alright, so in the previous video, we stopped it at a situation that random sampling generates non-representative sample. Okay, so to fix that problem, people typically apply the so-called stratified random sampling. Stratified random sampling. What's that? We first split the whole population into several strata. Each stratum is simply a category or a group. Okay, and also we say data in one stratum should be somewhat homogeneous, and data in different strata should somewhat be heterogeneous. Okay, what does that mean? Just consider the previous examples about randomly select 1,000 voters in Taiwan. If we think sex is an attribute that will significantly affect people's preference, then we should create two groups. Okay, two groups. One are male and one are female. Then we have two strata. And then why do we do that? It's because we believe within the category of men, people's preferences are somewhat homogeneous. People tend to have the same preference. Or when we compare the two strata, then their preferences are significantly different. Okay? So that's the idea that within a group, the data should be similar to each other. Their preferences should be somewhat similar to each other. And within, between or among different strata, their data are somewhat dissimilar. Okay, the preferences are somewhat different. So, in our example about double major, suppose we have 100 double major students, then we can split the whole population into two strata, right? One strata we have double major. The other stratum we have no double major. We have the sample strata size in each case. And then if now I want 200 students, instead of doing a random sampling, now I will restrict myself to get 20 students from the double major group and 180 students from no double major group. Okay? In this case, we are doing the so-called proportionate stratified random sampling. We generate the random sample based on the relative size of each different strata. And with that, we can somewhat make sure that our random sample has a better representativeness of our model, of our population. Sometimes we may want to do disproportionate stratified random sampling. Okay, this is of course not so common, but sometimes if we think the opinions in one stratum is more important than the other strata, then we may need to do that. For example, if today we are asking whether to construct a nuclear power station at a particular place, then people living around it and the people living far from it definitely may have different preferences. And in that case, sometimes we may need to consider those guys that live around that nuclear power station more. Okay, they may be some groups of people that we need to take care of if we really build a station there. So in that case, if we are sampling from all the people in Taiwan, then we may need to have disproportionate sampling so that we may get some relatively more data from those people who live around them. Okay, that's just one example. But in general, for most of the cases, if you want to understand your production process, if you want to understand consumers, and so on, typically we only apply proportionate stratified random sampling. So sometimes we may split a population we split the population into multiple groups on different dimensions. For example, we may consider that whether we have double major is one attribute that may affect the outcome. And also we may consider the year of graduation has another impact. So we have different classes from 94 to 98, from 99 to 03, and from 04 to 08, and so on. We may split the population into multiple strata according to multiple attributes. Okay, that's something you may need to do if you think there are multiple factors that may significantly affect the outcome. Sometimes we cannot identify all the potential factors. Sometimes we are not confident about whether one factor really has significant impact. Then, of course, we simply try to do our best. If we are sure that one factor really affects the outcome, then we need to consider that as a factor when we do stratified random sampling. So, stratified random sampling is good in reducing sample error. Sample error is simply the degree of non-representativeness of our random sample. Okay, we can lower the possibility of that. But of course, the bad side is the downside is that it can be hard to identify a reasonable stratification. Okay, if actually whether people graduate far from today or just yesterday, if that graduation year does not really affect their preferences or the number of credits they take, then doing that stratified random sampling is simply wasting our time and money. Okay, and also the reason that we typically prefer random sampling is obvious. It's just that sometimes we just cannot control how to sometimes we just cannot control who is going to be surveyed. For example, one of the most popular way to do some survey is to simply post a questionnaire online because it's cheap and it can reach a lot of people easily. But then it would be very hard to specify groups for this kind of questionnaires. Okay, so anyway, you know the concept, and you also know it's good the downside and upside. So whether to use it is your decision. Another way that is somewhat opposite to stratified random sampling is called cluster or area random sampling. So the example is here. Suppose you are a product manager and you are going to introduce a new product in your retail stores in Taiwan. Okay, so there are many retail stores in Taiwan, from north to south, from sea to mountain. And your question is, you don't know whether the product will really be popular. Okay, so if you push the product to all the stores in one shot, then you may incur a huge loss. So that's something that you may not prefer. You don't want your decision to be too risky. So if you want to get some idea about the popularity, one possible way is to introduce that product in a small area first. Okay, we may put that product to our stores in a specific area or to just a random sample of stores. Okay, if you have 1,000 stores in Taiwan, you probably select 10 stores or 50 stores and try to sell the product around in those stores. Okay, that's going to lower the risk for you to introduce this new product. Then we get this idea of cluster or random sampling. Okay, the idea is very simple. I split the population. In this case, the population is the 1,000 retail store. I split the population into clusters or according to their geographic location, which means area. And then I select one or multiple clusters. And once I do that, I select all the stores there. Okay? So that's the reason. That's the way for doing that. So we define clusters according to typically their geographic location. But in general, we define clusters and then what do we do? Once we select a cluster randomly, then we select all the data in that cluster. So if you are the product manager in Taiwan, you probably split your stores into, let's say, 4 groups, north, south, west, and east, west. And then you randomly select one group. Then you push the product to all your stores in that group. That's the idea. You randomly select one or some clusters. And once you do that, you collect all the data there. Okay? Sometimes, if your cluster is too large, we may further split it into second stage clusters. That's definitely something you may do. So because we are doing that, now we prefer a different property of our clusters. So clusters and the strata, they are different. How? In this case, we want data within a cluster to be heterogeneous, and the data across clusters are somewhat homogeneous. Okay? If you only push your product to the north side of Taiwan, okay, then you are saying that this is an experiment. We want to see how people like the product at the north side of Taiwan. Okay? Then you really want people are not all the same in the north side. Okay? So that you can really do a meaningful test. You want those guys in the north side of Taiwan can really represent all the diversities of Taiwan. So you hope people in the north side are not all identical. Okay? You need a cluster. You need data in a cluster to be heterogeneous. And then you hope that people in the north side can also somewhat represent people at the south side, people in the west side, and people in the east side. So you need the data across clusters to be somewhat homogeneous. So this is exactly opposite to stratified random sampling. In stratified random sampling, you want data in a stratum to be homogeneous, but data across strata to be heterogeneous. Okay, so it should not be too hard to understand their differences. In practice, the reason to do cluster random sampling is due to feasibility or due to convenience. Like if we want to push new products, if we do random sampling in Taiwan, we may randomly get the outcome as 2 stores in Taipei, 5 stores in Tainan, and 10 stores in Pingdong, and maybe 2 stores in Jinmen or Penghu. The stores that are randomly selected may distribute around the whole island of Taiwan. Then it would be somewhat hard for you to do the logistics. Okay? So if your chosen stores are close to each other, then the thing will be much easier. So that's the reason for we to do cluster random sampling in this case. If you need to do something, if you need to take some action after you do the random sampling, and if that action is easier to do when those guys are somewhat close to each other or have some same property, then you may want to do cluster random sampling. That's the idea that's the timing for applying cluster random sampling. But of course, you need to somehow make sure that again, your data, your sample has your sample can represent the population to some degree. Otherwise, doing this again will be dangerous. So lastly, we want to briefly go over some non-random sampling techniques. For example, there's something called convenient sampling. You simply ask those guys that you can easily reach. There is something called judgment sampling. Judgment sampling is that I, as a researcher, or I, as some guy who do the survey, I decide who to ask or what data to collect. That may happen when I particularly need the opinions from some experts. Okay, then I decide who to ask. Then that's non-random instead of random. Sometimes we do quota sampling. That's the idea here. We have multiple strata, and then whatever method we use, we do the easiest way to fill a quota in each strata. Okay, we know that in each stratum we have a certain number of sample to collect, and then within each stratum we use the easiest way to fill that quota. So again, this is non-random. Finally, there is something called the snowball sampling. So we ask one guy, and then ask that guy to suggest other persons for we to ask. In general, when you have different kinds of problems, you may want to apply these different techniques. But as we mentioned, as long as your outcome is deterministic, then there is no role that can be played by statistics or by statistical inference. Okay, so we will only talk about random sampling techniques, or we will only apply random sampling techniques in this course. Well, actually, that also happens in most of the market survey or quality control problems in practice. Okay, we will only focus on random sampling. Thank you.